Hello, this is Math 2231 coming to you from the College of the Page for Summer 2020. This is a continuation of a lecture to infinity and beyond. This is the second. When last we left off, I posed you to work on this. Some of you probably completed it. Some of you may not have, so here's your opportunity. You know what to do. Let's see how you did. Well, here if we factor the numerator and denominator, we cancel out this common factor. So that means that this is equal to this whenever x is not equal to 2. And 2 is not in the domain of this function. So you see the function is undefined when x is equal to 2. That's a whole. It is 0 over 0. But after we cancel out that common factor, we see that there is an asymptote, a vertical asymptote at x equal minus 2. So x equal 2 is not a vertical asymptote, it is a whole, as shown. But at x equal minus 2, it is a vertical asymptote. Here's another example. You have two problems to do. Notice that these are one-sided limits you're to compute. You know what to do. Let's see how you did. And that's the statement of the problem. So here's the solution. So what we're going to do is we'll see that we get the limit from the left is infinity, the limit from right is minus infinity. And that means that the limit as you tend to 1 does not exist because the left is not equal to the right. Here's a theorem about doing arithmetic with infinite limits. Okay, so here we're saying the limit is x tends to c of f of x is infinity, and this is L, and there are similar theorems that you get for minus infinity, and you should create those yourself. But if we add something to infinity, we get infinity. Or subtract something finite from infinity, we get infinity. If you multiply infinity times something finite, you get plus or minus infinity, depending on whether L was positive or negative. And as x tends to c of this is equal to 0, because you end up getting something that's getting infinitely large over something that is finite. And so the infinite thing will make that into 0, either from the negative side or the positive side. And here's some examples. So if we were to have this limit is equal to infinity because this one goes to infinity. If we had this limit as x tends to minus 1, you just plug it in. And this one, as you go there, you're approaching the cotangent of minus pi, so you get minus infinity. So that means this limit is going to be 2 over minus infinity, which will end up being 0 because it gets closer and closer to 0. And 3 times cotangent, that will be 3. This will be infinity, and so the answer will be, this one will be infinity. Here's some true or false exercises that sometimes are really useful. You know what to do, and let's see how you do. Alright, the first one is going to be false. An example would be this will never, the denominator will never be 0. This will be true because polynomials have no denominator. This one will be false because tangent x has asymptotes at odd multiples of pi over 2, odd integer multiples of pi over 2, and this is true. F is undefined because infinity is not a real number. It's not in the domain of f of x. See you in